Namaste. I am Bhumika Gupta and I am here to teach you the most important topic of class 11th chemistry is VSEPR theory. What does VSEPR stand for? VSEPR stand for valence shell electron repulsion pair. VSEPR stands for valence shell electron repulsion pair. Okay, anyone in the classroom who can tell me that why water molecule and CO2 has different shapes where both has oxygen molecule. Anyone? No one? Okay. Water molecule and oxygen molecules both have different shape. It is because of valence electron pair. Okay. Anyone in the class who can tell me about what is valence shell electron pair? Okay, I will tell you about the valence shell electron pair. What is valence shell electron pair? Valence shell electron pair is the electron pair of electrons in the last orbit. Let's take an example to understand this. Let's take an example of NH3. How many valence shell electron pairs are present in nitrogen? Okay, first tell me the atomic number of nitrogen. Atomic number of nitrogen is 7. So, how we will write the electrons in orbits 2 and 5. So, how many electron pairs are there in valence shell electron? It is 5 electrons are there in valence shell electron. Okay. In case of CH4, how many valence shell electrons are present? Atomic number of carbon, it's 6. And how we will write it? Write the electrons 2 and 4. So, how many valence shell electrons are present in carbon atom? There is 4 valence shell electron. 4 valence shell electrons are present in carbon atom. Okay, now class, you will tell me that how many valence shell electrons are present in oxygen atom. Okay, first tell me the atomic number of oxygen. Okay, atomic number of oxygen is 8 and there are 6 valence shell electrons present in the oxygen atom. Okay, let's move to the VSEPR theory. Okay, Okay, what is the answer behind the question that why H2O molecules and CO2 molecules have different shapes? Okay, the answer is it is because of valence shell electron pair repulsion. Okay, now the why valence shell electron pair theory has been discovered, why VSEPR theory has been discovered. Okay, this theory, okay, let me tell you, this theory has been discovered to predict the shapes of the molecules. Okay, now Now we will read about the postulates of this theory. It explains the shapes of the molecules by the assuming the electrons of assuming that electron pairs around the central atom repels each other and arrange themselves as far apart as possible. Okay, what this postulate does mean? This postulate is saying that electron pairs are try to arrange themselves as far as possible. Why? Because electron pair around the central atom repel each other, and what we have to do is we have to do the minimum repulsion. There should be the minimum repulsion in between the electron pairs. Understood? Okay. Now, who gave this theory? This theory has been given by Ronald Gillespie and Ronald Nylom in 1957. Okay, what is the purpose behind the theory? To predict the molecular geometry, to explain the bond angles and molecular shapes, and to understand the how electron pair repulsions affects the structure. This is the main purpose of this theory. Okay, let's comes to the postulate of VSEPR theory. So first postulate is electron pairs repel on one another. Okay, so the electron pairs around the central atom repels each other. The second postulate will be electron pairs arrange themselves to minimize the repulsion. Or we can say that one pair of electron in valence shell repel another pair of electron because they are negatively charged. So as we know, same charge repel each other and opposite charge attracts each other. So what is the third postulate? Lone pair repulsion is the maximum repulsion where lone pair bond pair repulsion is the lesser and bond pair repulsion is the minimum one. Why so? Anyone in the class who can tell me why so? Okay, I will tell you. The lone pair repulsion means both the free electrons. Let's take an example that if two peoples are in the house and they both are free and they are doing nothing, then what they will do? They will do they will blame each other for household things. So if they blame each other, they will fight, which means repulsion will create. And now let's consider the another example for lone pair bond pair. Lone pair is the free electrons and bond pair is the working electrons, which makes bonds. Okay. So if bond pair, let's consider it by taking an example. If two peoples are in the house, one will go to the office and another will be free, sitting free on the sofa and watching TV whole day. So the one who went to the office comes in the evening and said to the free person that why you didn't do anything in the home. That all the household things were on the same place where they are in the morning. So repulsion has been created between them. But the repulsion is not as maximum as repulsion between the lone pair repulsion. Okay. And now let's take a third example for the bond pair repulsion. Let's take two peoples are in the house and both are working. So they go on a work, do their work, and come to when they come to home, then they will tell each other that let's do this. You will make dinner. I will do the cleaning, and they both are working. So there will be no repulsion. That is why lone pair are the free electrons. Lone pair are those free electrons which do not participate in bonding, and although they do not form bonds. So lone pair repulsion are maximum, and lone pair bond pair repulsion is little lesser than lone pair repulsion, and bond pair repulsion is the minimum repulsion. Okay, now the fourth postulate is molecule shapes depends on the number of bond pairs and lone pairs. Okay, the fourth postulate means the molecule shape of the molecular shapes depends on the number of bond pairs and lone pairs. Okay, anyone in the class who can tell me what is lone pair? Okay, the lone pairs are those pair of free electrons which do not participate in bonding. Okay, let's take an example of NH3 again. Let's take an example of NH3. How many electrons are in valence shell? 5. Okay, see. Now nitrogen has 5 electrons. It will form bond with 3 pair electrons, and rest 2 electrons are known as lone pair of electrons. These two these two electrons are called lone pair of electron. Okay, now understand what is the lone pair. The lone pair are those free electrons which do not participate in chemical bonding. Okay, now comes to the fifth postulate, that multiple bonds occupy more space than single bond. Multiple bonds occupy more space than single bond. As we all know that single bond occupy lesser space and multiple bonds occupy more space. We all know that. Okay, now let's understand some structures, common molecules and their structures. So let's come to the first structure, AB2 type, structure of AB2 types. Okay, this theory is also applied to the resonating structures also. Okay, okay, let's first predict the structure of AB2 molecules. AB2, A is the central atom which has two electrons, A, B and B. Okay, what is the geometry of such type of molecule? Linear. So geometry of AB2 type of molecule is linear. Okay, anyone tell me the example of AB2 type? Okay, BeCl2 is the example. Okay. How many electrons are present? How many valence shell of electrons are present in Be? Be has 4 valence shell of electrons. Okay, how many? 4. So, what is the geometry of BeCl2? Beryllium has 2 electrons present as a valence shell electron. So, the geometry of beryllium is linear. Understood? Okay, now consider. Let's take an example of AB3 type of molecule. Okay, how many valence shell electrons should be there to make the geometry of AB3 type of molecule? Anyone in the class? Okay, AB3 type of molecule. We need valence shell electrons. How many valence electrons? 3. 1, 2, and 3. AB, AB, and AB. So, what is the geometry of AB3 type of molecule? Geometry of AB3 type of molecule is trigonal planar. Anyone in the class who can tell me the example of AB3 type of molecule? Okay, BF3 is the example of AB3 type of molecule. Okay, how many valence shell electrons are present in boron? 3. So, all the 3 electrons of boron make a bond with electrons of fluorine. So, what is the geometry of BF3? Trigonal planar. Okay, now let's take an example of AB4 type of molecule. Anyone in the class who can tell me the AB4 type of molecule? What is the geometry of AB4 type of molecule? Anyone? No one in the class? Okay. So the geometry of AB4 type of molecule is CH4. Okay. First we will see the geometry of AB4 type and then we will take an example to understand this. So the geometry of AB4 type molecule is tetrahedral. What is the geometry of AB4 type of molecule is tetrahedral. And how many valence shell electrons the central atom has to have AB4 type of molecule or a geometry of tetrahedral? 4 valence shell electron pair a central atom must have. Okay, this is the tetrahedral geometry. So, anyone in the class who can tell me the example of AB4 type of geometry? CH4. CH4 is the example. Okay. How many valence shell electrons are present in carbon atom? 4. So, carbon has 4 valence shell electron. It bonded with 4 hydrogen atom to complete their octet. And it will form tetrahedral geometry. They have an angle of 109 degree 5 minutes. Okay, now let's take another example for AB5 of molecule. So how many valence shell electrons are required to make AB5 of geometry? Anyone? Central atom has 5 valence shell of electrons. Okay, AB5 AB5 has trigonal bipyramidal geometry. Okay, how to make the trigonal bipyramidal geometry? See, this is the shape of trigonal bipyramidal geometry. Why this is called trigonal bipyramidal? Uh, Triangle, we have triangle, and the one pyramid is made up in the above, and one pyramidal is in below. That is why this geometry is known as trigonal bipyramidal. Example of TBP geometry is PCl5. Phosphorus has 5 electron in its valence shell. So PCl5 has trigonal bipyramidal geometry. These all are the examples of regular geometry. VSEPR theory has been divided into two types of molecules, divided into two types. First, which shows the regular geometry, and the second one which shows the distorted geometry. Uh, what is the reason behind the distorted geometry? The reason behind the distorted geometry is presence of lone pair of electron. After taking one more example, we will discuss about distorted geometry. So the second example will be, okay, the last one is AB6 type. AB6 type. Anyone in the class who can tell me the geometry of AB6 type of molecule? Okay, the geometry of AB6 type of molecule is octahedral. It has 6 valence shell electron which form bonds with another 6 valence shell of electrons to complete their octet. This is an octahedral geometry. Okay, example of octahedral geometry is SF6. Sulfur has 6 valence shell electron pair, whereas fluorine has 1 electron in their last orbit. To complete their octet, they form bond with, they share electrons with the sulfur atom so that they all can complete their octet. So SF6 has octahedral geometry. Okay. Okay, now let's take an example of distorted geometry. Okay, the first example will be NH3.